maybe you are tired, last slot of the second day. I'm a bit tired too, actually. Plus, I forgot to put nice animals on my slides. Sorry about that. And I am Michele Orselli. I work for Ideato, which is an Italian company based in Cesena. I don't expect you to know where it is, but still. Here are my contacts. And I'd like to start talking about the scenario where we developed this project, which is about synchronizing data between mobile application and a server. Then I will highlight some design choices we made in that context. After that, I spend a couple of slides, a few more actually, on the implementation for an high-level point of view, and I'd like to show you some code. In the end, if there is still time, I'd like to talk about some alternative approaches. What I'd like you to get after in the end of the talk is a nice overview of the topic of synchronizing data between mobile applications. Now, phones, mobile applications are everywhere. We use it every day, every time, when we are sleeping, where we are in the toilet, in the bathroom, and as Jordi said before. And that's even more true in Italy, where cable connections are quite bad, and a lot of people use phones as the main way to access the internet. And it's becoming more and more common for us to expect to be able to work, even to use our applications, even if we are disconnected. Okay, that's a really common use case, because maybe there's no signal where I'm in the certain moment, or because I am in a foreign country and I don't have, a data plan like me in this moment. So basically, what we like to do is to continue using our application, and then in the end to get the data on the server in some way. Here is a really simple or silly example. We have basically 3 nodes. When we're talking about this stuff, basically we have distributed systems, because we have a server and several clients that need to communicate each other. So actually we're talking about a distributed systems. In this case, we have 3 nodes, the red one, the green one, and the blue one, which are producing different data, each other. And what we like to happen eventually in the end is that by communicating in some way, in the end they share the same data, okay? At the end, every data produced is synchronized on every node. Fine. In this scenario, we also need to deal with conflicts, because what happens if 2 nodes work on the same data and they modify in a different way? Okay, in this example, the blue node modifies the record from A to A1, and the green one modifies the record to A to A2. What are we supposed to do? Should we throw one of the 2 records away? We keep both. Maybe we can let the user decide what to keep. Okay? Should we use domain knowledge to make these kind of decisions? Okay? We answered all of these questions for our particular project, and I'd like to share some of this stuff with you. In our case, we were starting with a brownfield project, so an existing project which consisted of several mobile applications, 3, if I remember correctly, for tracking user-generated data, like calendar entries, notes, even biological data. The domain was health for children, so I'd like to track information about my newborn baby, weight, body temperature, and stuff like that. 2 platforms were targeted at the moment, iOS and Android, and when we took the project, there were a user base of 10,000 users, growing at the rate of more or less 1,000 user per month. The data layer was based on MongoDB, and unfortunately, the app was a legacy application based on CodeIgniter, really nice, fat, enormous controller with a lot of if everywhere. And there were an existing API for data synchronization, RPC, but I'd like really to be REST, please love me, style. Okay, they were actually quite simple. For every resource we had two endpoints, one for getting updates from the server, where you need to specify the application string identifier, the user ID, because all the data are related to a single user. Okay, there's no sharing of data between users. The resource name, and eventually an update and from parameter, which allows you to say just I want the changes from this time and not before. For sending updates to the server, you have to use another endpoint where you need to specify again the application identifier, the user ID, the resource ID, the device ID, and the resource name. Okay, so far so good, almost. In this scenario, this kind of API makes little sense, at least to me, because for every application we had on average 6 different resources. So one synchronization round trip took 12 calls, and apps sync by polling the server every 30 seconds. But every call syncs very little data. So basically the scenario was at certain time of the day, the server was flooded by requests. They transferred almost nothing. So the challenge for us was try to rebuild this synchronization API for the old applications, plus 2 more applications incoming, and enable image synchronization, which was not possible in the previous API, and of course to provide them more efficient way to do this kind of stuff. Okay, so what we did, sorry. Well, we tried to don't reinvent the wheel, and we tried to find what information were available, what systems or protocols or API we could use for this problem. There are a lot of information out there. Basically, you will find a lot of algorithm to deal with this kind of stuff based on timestamps or vector clocks, which is a quite famous implementation in this area, and the new data structure, which I hope to have time to talk about it later. You will find several protocols or API like SyncML, which is a not so a bit old, actually, protocol for synchronizing data like calendar nodes, events, and stuff like that for PDA. Also, there are a couple of documental databases which embraces the fact they are distributed, and so they help you in identifying and resolving conflict when merging data. For example, RIAC and CouchDB do this kind of stuff. Also, you will find a lot of platforms that offers you API for dealing with this problem, like Azure Data Sync, but also Dropbox has its own API, which are called Data Store API, if I remember correctly. So there are a lot of information, a lot of data out there. So what do? We just try to build our own solution, or we try to use one of the things that already exist? Well, in our particular context, since we need to target 2 different platforms, iOS and Android, and we had several teams with several skill levels, in particular on the mobile side, mobile application developing side. And for us, it wasn't really a viable choice, changing the storage, like changing maybe MongoDB for Couch or Ryak, and forcing a particular technology on the client side, again, wasn't an option because there were several teams and it wasn't possible. So what we decided to do? We decided to develop our own solution, and which is not really complicated. And the first choice was to put all the synchronization logic on the server. Basically, the client are really stupid dumb in a certain sense. Okay, they just only manage their own data, but they don't do merge or resolve conflicts in any way. They just ask the server to do it for them and then get back one response. So this was the first choice. Again, in the synchronization domain, if you think about it, all the resources are managed in the same way because I'm not interested if I'm dealing with I don't know, measure that represent a body temperature or a calendar note. I just want it to be synchronized in the same way. Okay, so basically, we decided to define for every application 3 endpoints. One endpoint for getting new data. Okay, so the mobile client doesn't have new data, I just want to get the update from the server. One endpoint for pushing new changes. Okay, so while I was disconnected, I created new data, and then I just push it to the server, which will try to resolve conflicts and give a response back to me. And one endpoint for uploading images. We decided to keep a separated endpoint for this for this particular feature because in this way the data we're going to transfer and we're going to sync remains small, and we don't need to deal with big images. Okay, we transfer them as I will explain after in two steps. Okay, so these are the endpoints for the new APIs. Pretty simple. Okay, the first one is for getting new changes. You have to specify application name, user ID, and eventually a from parameter, which allows you to define where you want the instant of time where you want to get updates from. The second endpoint is for merge. Okay, again, you have to specify the application name and the user ID. And the third endpoint is for uploading images. Okay, so now I'd like to spend a couple of slides on the Silex implementation. Basically, for every application, every mobile application, we have at least one MongoDB collection involved. Okay, so let's say we have 3 different collections here. And we have a synchronization service, which basically deals with all the conflict resolution stuff. And all of these things are wrapped in a Silex application. So when a request arrives, basically it is wrapped in an object which is passed to the synchronization service. The synchronization service uses a repository to understand what collection are involved for the particular request and to get the data from the collection. After that, it performs the conflict resolution and synchronization logic, and it produces a response, which is after that given to the mobile client. Okay, so it's actually pretty simple. Does it make sense to you? I hope so. Okay, feel free to interrupt me if something is not clear enough. And okay, let's see a bit of code. Again, it's really simple. Here we are defining a route with Silex, and the code for dealing with this kind of stuff is here a really thin layer because all the logic is inside the synchronization service. The first thing we do is we get the from parameter to understand if we need to consider data only from a certain instance of time, for a certain time. After that, we use the sync service to build a request, okay, to get the new data for the mobile client, and then we produce a JSON response which is returned to the mobile client itself. Okay, this was the case for getting new changes. Okay, a mobile app doesn't have new data, but what was needs only to get data from the server. In that case, here we are dealing with the merge. So I have some data I need to merge. What I need to do is to get again the from parameter and that the data in the request. I'll use again the sync service, passing the data array, the last synchronization time, and the user ID. All the merge logic is performed, and then again a response is produced and returned to the mobile client. Server definition is quite easy again. Basically, we have the synchronization service, sorry, there's a typo here, and which uses a changes repository, which is in charge of finding all the record in the collection involved in a certain transaction. And that's all. Okay, I'd like now to spend some time talking about several choices we have to make for building up the algorithm. The first one was about the from parameter. Is it a timestamp or a version number, incremental version number? Okay, in the first version of the APIs, this parameter was actually a timestamp, and it was generated by the mobile client, which maybe it's a bit inaccurate because you cannot be sure that the clocks are synchronized, so you can lose data, maybe. And so we decide to use a from parameter that is suggested from the server to the mobile clients at every request. Basically, how it works. Sorry, in the first request, we are issuing a changes get request, and the server responds with the array of data we need to integrate in the mobile client and a next parameter, which means, okay, the very next request you are going to issue, just use this parameter in this way, okay? So on the second request, the mobile client appends this parameter and the request, and then the servers knows that it needs to take care of data just from that given instant of time. In this way, we don't have to deal to timestamp generated from the mobile application. Okay. Another thing we thought about was what kind of data you may transfer, okay? Basically, you have two choices. You can transfer operations. So if I am creating a record on the mobile application, and then I editing it, and then I maybe editing it again, the logs of the operation will consist of 3 records, okay? Add, update, and update. And maybe you can transfer it to the server, which is, you have a lot of information because you are keeping track of every operation done on the mobile client, but it can be a bit difficult to reason about it and to decide what to do. A simpler way to deal with it is to transfer states. So basically, I don't mind if I modify a record 30 times or 40 times, or I just need to know where is its final state, okay? And just I need to transfer, I just transfer it to the server. Okay, so we choose to transfer states. So basically, here's an example of the data passing through the wire. You have an ID, a type, which allows you to identify which kind of record you're dealing with. And a really important thing is to do not physically delete records, because you won't be able to do reasoning about that, okay? If you physical delete a record, you are just lost it. You have no information that it was present on the mobile side, in the mobile client. So it will be difficult for the server to reason about it. Okay. Well, in a distributed system, you cannot count on a standard, no, actually not so standard, but for small application, it's quite normal to use auto-generated IDs, okay? Well, that's not true if you are using Mongo or stuff like that, but it's pretty normal. In a distributed system like that, how do you identify a record in a unique way? Okay, how can be sure to do not generate conflicts with generating IDs? Basically, you have two ways of dealing with that. The first one is using global unique identifiers, okay, which is, there is an RFC. Basically, you are going to create a quite long identifier, and you are pretty sure that it will not collide with any other ID generated on different machines. Or another approach is to use local and global IDs, which is the choice we made for our use case. Basically, only the server is going to generate global unique identifiers, okay? And the clients can use their own local IDs, okay? It doesn't matter if they are auto-increment or I don't care, because they are only valid for a given local mobile device, okay? When we are going to synchronize the data, the server is in charge of generating a global unique identifier for the record who doesn't have one. Okay, here's an example. Basically, we are transferring two records with, as you may see, local identifier 1 and local identifier 2. Okay, the server saves this data on Mongo and then generates a global unique identifier, and it responds back to the mobile client, which can update his own records. So basically, mobile generated data are temporary until they are synchronized with the server. And as I said before, the server is in charge of handling conflict resolution. Okay, the client basically don't do nothing. For dealing with conflict resolution, you can choose different strategy, actually. The first one is to basically use a domain-independent solution. So just you decide that the last write, the more recent record wins, okay? And that's it for every type of record in an independent way from the domain. Or you can choose to use domain knowledge to resolve the conflicts, okay? Yeah, okay, just maybe the default rule is that for every record, the more recent wins, but if the record is, I don't know, a calendar entry, maybe the entries coming from mobile apps wins. Okay, you can just choose rule like that, depending on your actual domain. Now I'd like to talk a bit about a possible conflict resolution algorithm. I start with the simple one and try to add complexity step by step. The first case is for dealing with plain data. With plain data, I mean record with no relation, just a simple plain record. So I don't expect you to read it, but it doesn't matter. And basically, what we do is when we receive a new data packet from a mobile client, we try to, first of all, see if is a record already synchronized. Okay, so if it's present on the server. If the record is not present on the server, well, basically we have no conflict. Okay, we just need to integrate to add the record on the server and to send the response to the client. Just telling him, yeah, just update it. Just add this global unique identifier to this record. If the record is present, we need to check which of the two is more recent. In this case, if the record coming from a mobile app is more recent, it wins in a certain sense. So we update the record on the server and then we respond back to the client again. The last case is if the record on the server is the more recent, we just don't need to do anything and we respond back to the mobile client. Okay? Makes sense? I hope so. Okay? Here is a little example. I hope we can maybe clarify a bit things. Here we have basically 3 records. Okay? 1 on the server side and 2 on a mobile client. One of the records on the mobile client was already synchronized. So what happens when we try to merge these changes? Okay, a merge request is issued, and what happens? Okay, the first record, the one with local identifier 2, is not present on the server, so it is just added and stop, we're done. The other one, we just try to match by global unique identifier and we find a match on the server, so we need to compare the records to decide which is the more recent. In this case, for instance, the record coming from the mobile client is the most recent updated, so we update the one on the server and then we return a response to the client. In the response, we specify what action the client is supposed to do. In this case, just update the global unique identifier for the record. The record was with the local ID 2. And for the second record, yeah, basically you have to do nothing because the record was the most recent. Okay, and let's complicate things a bit. How can we manage hierarchical data? By hierarchical data, I mean records which are related in some way. Okay, basically where in one field there is an ID pointing to another record. This is done in 3 steps. The first one, you need to synchronize the root record, the main record, I don't know how you want to call it. Then update the IDs of the record that are referencing it, and then you can synchronize the child records. Again, there is a snippet of an algorithm. The first operation you need to do is just sort the data coming from the mobile client. In this way, the parent records will be the first one, and you start processing it. After that, if the record is a root record, okay, and if it's not present on the server, is not on the server, basically you have no conflict. So you need to add this record on the server and then update the reference coming from the mobile client, okay? And then you just need to produce a response from the client itself. And if the new root record is present on the server and is more recent, again, you need to do You need to update the record on the server side, update again the record IDs, and then respond back. The last case is if the servers contains a most recent, more updated record. In this case, you need to update record IDs referencing that particular record, and then again you have to respond to the client. If the record we are dealing with is not a root record, so it cannot be referenced by other, well, the algorithm is the first one I presented. Okay, nothing changes in that case. Again, there is an example. I hope it will help to clarify things. Here we have two records. The first one with local user ID 1 and is not synchronized yet, and the second one with local ID 2, sorry, and it contains a reference on the first record. So what happens when we issue a merge request? We are trying to first synchronize the root record, the one with local ID 1, and we assign a global user ID to it. Yes, sorry, the global unique identifier to it. After that, we update the reference on that record because now it's synchronized, and we can synchronize the second record. After that, we can produce a response for the mobile client when we tell him just update the first record with local ID 1 and the record with local ID 2. Just assign this global unique identifier to them. Okay. One last step is enforcing domain constraint on this kind of algorithm. For instance, only one body temperature can be registered in a given day. This was an example of a domain constraint we had in our application. And how do you deal with it? Well, the easy way is relax these constraints. So what happens if I add 2 temperatures in a given day? Well, maybe nothing. So you don't have to write code to manage it. Less code means less bugs. So if it's a viable solution, go for it. Or you can basically integrate constraints in the synchronization algorithm. How can you do that? In the previous slides, I defined a find by GUID, which basically look for a record with a given global unique identifier. Well, now we need to use a find similar, okay, which performs first a lookup by global unique identifier and then by a specific domain rules. For instance, 2 measures, 2 temperatures are similar if they are referred to the same date. So basically, how it's working, how it works. Sorry. On the server, we have, for instance, a record which is synchronized with a field when, which defines where that particular measure was taken. Okay. On a disconnected client, we create a record with the same date. When we issue a merge request, what happens is first we look for the record on the server by searching for its global unique identifier, but since it doesn't have one, we will not find anything. Then we look for similar records, which is records that have the same value in the when field. Okay, in this case we find a match, so we can perform the conflict resolution logic and then give a response to the mobile client. Okay, still makes sense? I hope so. The last bit to complete the algorithm is dealing with binary data. As I said before, binary data are uploaded via custom endpoint. So in this way, the synchronization packet, if you want to call it, remains quite small. And again, uploads can be resumed. Okay, thank you. So you can achieve it in 2 steps. First, data are synchronized, like I showed you before. Sorry. And then the related images are uploaded, okay, asynchronously. This means that you may have a record with the reference of an image that doesn't still exist on the file system because you still not have uploaded. Again, here is another example. Here we are trying to merge one record, which has a local identifier of 1, type baby, okay. We have a field image, which contains the name of the image. Everything goes smooth, so the servers produce a response for the client. After that, in a second moment, we try to upload the image by specifying the resource identifier, by specifying in particular is global unique identifier, and then upload the data as binary data. And basically, that's it. Okay, so what we learned for this experience? Well, implementing this kind of stuff is a bit tricky, and yeah, maybe it can be helpful to explore existing solution if you can. And understanding again the domain is important because a lot of choices we made are particularly tied to this specific domain, and they may be not hold in another context. Okay, so I have some few extra slides, but about alternative approaches, I skip a couple because there's no time. An interesting approach I think is worth mention is dealing with the kind of stuff at the database level. In particular, we found 2 solutions. One was Couchbase Mobile. Basically, you can install a local copy of your CouchDB database on the mobile app. And the nice thing about it is that you can use a library to manage data synchronization. Is quite cool, in my opinion. I will give it a try if I can. And another product is Ryak. Again, it's a distributed database, key value store actually, with complex data types. And the nice thing about that is that you can you get automatic conflict resolution for built-in data types, or you can choose to configure it and deal with it at application level. So I think it's worth mentioning. Okay, so that's all for me. Thank you for listening, and if you have questions, I'm here. So, question? Yeah? Yeah? Sorry, I try to repeat the question. What happens if the client doesn't receive an... Okay. No, actually, we haven't experienced it, but yeah, I imagine it can happen. Basically, you will try to generate a response, and we didn't think about some kind of hack for this, but yeah, we haven't experienced problem, as for now. So in theory, it's possible. Yeah. Other questions? Yeah?
It was difficult to test such application. I mean, automatic testing.
Yeah, just actually no. I mean, it was quite easy to write integration test faking the mobile clients, but it took a bit of time for integrating with the real applications. Just even because the teams who developed the mobile application didn't do unit testing, no kind of testing. So it was quite time-consuming and difficult. But I guess that having tests helped us to mitigate the problem. But still, it was a bit time-consuming, yes. Okay, so we'll be around here for another hour. After that, the conference is over. So if you have other questions, reach me on email or Twitter or whatever. Please also leave feedback. Thank you very much.